Hey, this is Cinnabar again. I decided to goof around a little bit. I watched a couple of videos on the interwebs on YouTube about anodizing titanium, and I had never tried it before, and I thought it required a tremendous amount of equipment and chemicals, and it turns out you can do it very, very quickly and easily with just a couple of things you have lying around the house. So, specifically what I've got here is I've got a plastic container filled with water, to which I've added some baking soda to create an electrolyte solution, about a teaspoon or so of baking soda. I've got some aluminum in here, which is going to be one part of the project. I've got a pair of alligator clips, leads, and I've got three 9-volt batteries, which I'm going to chain together, pretty much straightforward, to create approximately, less the resistance, about 27 volts. I've also got some titanium. I've got these really cool titanium patches I found. I've got some bags of cleaned and purified rings, and I've even got some patches of titanium, which I've cleaned off, and a mixed titanium and stainless, which I'm going to see if it actually works. So the idea basically is that apparently all you have to do is connect with one of your alligator clips and one of your leads the negative side to the aluminum foil. These things are a little bit slippery while using. Why am I doing it with the gloved hand? Got to do things the hard way, don't I? All right, and then to complete the circuit, we'll attach to the positive side our hook, which I'm going to use to do the anodization, and one of our pieces. I'm going to go fishing around in here, and I have a small section of beat up half Persian 4-in-1. It's coming apart a little bit, which I have had on my keychain forever. Now, this is actually a mix of CP, commercially pure, and grade 5 titanium. And what I'm going to do is I'm going to dip this in the water, and theory is that within a couple of seconds I should see a color change, if I've done this right. So let's find out. In we go, and I don't see much happening. All right, so I'm seeing bubbles come up from the titanium. That's electrolysis as the hydrogen is liberated, and the oxygen bonds with the surface of the titanium, forming titanium oxide, which should create a layer of anodization. So I'm seeing a little tiny bit of bubbling, and I pull it up, and whoa! I dropped it. Get that back out of there. Wow! I don't know if this shows up very well on the webcam, but I got this very rich purple across most of the rings. That's crazy! That's cray-cray. Now the theory is, based on the amount of voltage I use, I'll get different colors. So that if I chain in a third battery here, I should get a different color across this. So I'm going to try that real quick. I'm going to dry off my hand a little bit. I got a paper towel over here. A whole roll of paper towels. So the theory is, if I chain in another 9-volt battery, I increase the voltage and I increase the amount of resistance that'll pass through the surface of this oxidization layer, and therefore change the spectrum color, change the refraction level that'll occur. So I'm going to go grab myself another 9-volt battery out of my box. I bought a dozen of these. I did not expect that kind of rich purple color on the first try. All right, I'll chain this one in sequence. I'll hook my alligator clip back to it. I will once again hook my chain, as beat up as it is, over the back end of this, and now I'm only going to dip a portion of this time, just to try and see if I can change the color on the bottom end. Okay, I'm seeing a little bit of bubbling, but not much, so I don't know what's happening yet, but I'm going to hold it for about 3 to 5 seconds more. 3, 2, 1. Let's see what we got here. Well, that's interesting. I got a lighter blue here at the end. I don't know how well that shows up, but if you look carefully, you can see that I've got more of a darker purple here, and then a lighter blue here. So if I chain in another one, I should get another color. That's pretty interesting for now. So I'm going to try something different, though, real quick, because that came out far better than I expected. What I'd like to do is, my understanding is the other thing I can do with this is I can take a fragment of paper towel or a sponge, I can clip it to the end of the clip here, dip it in the solution, get it nice and wet, and I can paint across a piece of titanium and create an oxidization layer. So I'm going to give this a try just on the right side of this patch, and I'll see what happens here. I'm not seeing much. This may not be working nearly as well as advertised. Oh, I understand what I'm doing. I need to actually clip this lead. I'm not creating a circuit here. I need to clip this lead directly to the piece of titanium if I'm going to do that method. So, we'll clip this lead directly to the titanium. Yay, insulated leads, difficult to work with. Okay. And now let's try painting across it. You see no good fail there. So, in theory, well, I can hear the sizzling. In theory, I'm creating a bit of an anodization layer. Now I can see the eye is changing color. And the numbers are changing color. The rest of it is not so much changing color. There may be some grease on the surface of this, which prevent the anodization from happening. But if you look carefully, I'm seeing some sizzling here. I'm actually cooking this paper towel, I think. Yeah, the anodization is occurring. Wrong place. I'm not getting anywhere with that. Oh, I burned that one up pretty good. Yeah, I apparently got this a little too wet. But that didn't work out as well as I had hoped. However, the theory is that if I reattach this to my foil and attach this lead, which got a little messy, back to the batteries, and back to the patch, I should be able to dip this patch and get the same effect. Let's find out. Okay, so I'm seeing all sorts of bubbling in here. I don't think the camera's quite picking it up, but I can definitely see a color change at this point, and I'll pull it out and look at that. Look at that bright blue I got there across half the titanium patch. That is très cool. So I'm going to disconnect that, and I'm going to try a larger patch just for giggles. I've got, I'm not sure why I'm drying this off. I've got a relatively large patch of titanium. I'll hook this in here. Now I'm looking for more of a purple on this, so I'm going to drop down back to 3 batteries. I don't know if this will work because I've used that hook with 4. This is part of the experimentation game. I've used that hook previously. I'm going to need another one to put that one up. I broke that one. Now, I'm going to carefully use the same exact color alligator clip that I just used just to confuse me. Okay. So I'm going to use my titanium rod, which I dropped on the floor. Tremendously well organized we are today. If I can get to it. There's the clip. Slippery little buggers. Okay, I've got my hook. Now the key is I can't complete this circuit via allowing the aluminum foil to touch the titanium, so I'm just going to push it back here a little bit out of the way. See what I'm doing here? I'm pushing it back. Grab my hand a bit. I'm only using a rubber glove not to protect myself, but to prevent myself from accidentally closing the circuit myself. See if the alligator clip's strong enough to pick up all this titanium. Okay, we're going to very carefully put it in one side and not let it touch the other side. And it has begun sizzling. It is sizzling nicely. I'm seeing a non-trivial amount of water come flying up, but I'm only seeing the ring in the end getting anodized here, the one corner ring. So it may not work with a patch this large, where the connection may not be good enough. Let's try hooking the center of the patch. See if that works. I don't know. I'm seeing some sizzling. There's something happening. There's definitely a reaction happening here. It's just happening very, very slowly. This is a very, very large patch. It's probably 300 or 400 rings. I'm seeing some change in color. It's just taking a while. It's probably because of the size of the patch. Yeah, it's definitely turned more of a golden, at least. Bronzish color. Not quite the purple I got off the chain with the 3 batteries. Let's take a quick peek here. Alright, so it got darker, but I do believe I need to use a new hook because this hook is probably not acting as a conductor anymore. It's probably got too much of an anodization layer on it. So I'm going to take a break, change the hook, get another hook, and then give this another shot. Okay? Okay, so I'm back here. I grabbed myself some more of my titanium rods, TIG stubs. These are, I got a whole bunch of these, about 7 pounds of this stuff from a guy named Master Newt, who does welded chainmail. These are the stubs left over from his welding of titanium. Pretty awesome. I was turning them into like a ring or 2 at a time at one point before I started losing my mind. In any case, they make good hooks. So just quickly bend this into a rough S hook. So the idea would be, and once again, I'm trying to get this purple across the entire patch here. This is a very large patch. I want to get this purple that I've gotten here on the chain across the entire patch if I can. I've got 3 batteries hooked up. I'm going to disconnect my old hook, which has turned a very nice shade of purple itself. See, it's gotten a light blue across the end. It's probably why it's not conducting electricity so well. It's built up that titanium oxide layer across the end. In any case, I'll put my new hook on there and semi-secure it. And I'll hook the end of this. Actually, I'll hook it in the middle. This way I'm distributing the electricity a little better. And we'll dip it in. Now, I'm going to be very careful not to get the clip in there. Let's see what we got here. I'm seeing a little bit of hissing. Not a lot. Oh wait, no, now it's starting to bubble. Alright, I'm starting to see some color change across the center where I'm holding it. This will probably take a while. This is very low amperage, and I've only got 3 batteries in sequence here. See, I'm not lying, 3. These are the cheapest Radio Shack batteries I could get. Figured if I was going to destroy some batteries, why the heck not? So, I'm seeing more bubbling. And somewhat of a color change, maybe not nearly as much as I had hoped for. Let's take a peek and see where we're at here. Alright, so I'm starting to see some dark color across the top here, some purple. It's not nearly as deep as it was on the other patch, on this small chain. So I'll dip again and see if we get a better color over more time. Or perhaps, if I change where the hook is connected, let's try that. You're going to be very careful not to complete the circuit and have the titanium touch the anode here. That's apparently a big piece of this. It's bubbling a little bit. Yeah, I might need a larger power source or a real anodizer for this to work. But hey, I'm getting some color change and I'm getting some bubbles. It might just be a matter of time here. Or if I just hang this here, see what happens in a couple of minutes. Right, we'll take a little bit of a break. I'm going to leave it here for a couple of minutes and we'll come back. And we're back. I let this sit for a couple of minutes. Part of the titanium was out of water and it's been hissing away, and it has turned across the majority of the patch an interesting shade of purple. Now here's these are unanodized rings for comparisons to the original titanium. You can see that there's a tremendous color difference here between what I had and what I This is what I had and what I ended up with. I ended up with this rich, vibrant purple. Now, it's across the entire patch. There's some variation towards the end where I didn't have it hooked. It's not quite as deep. I'm sure if I readjust the hook and dip it again, I might get a better color over here. And I'm willing to try that for a second or two, just to see if there's a difference. Again, I gotta be careful not to touch the aluminum on the far side. Let's see here. I don't think I'm getting much. Oh no, wait, see, it's bubbling again. So you can build up this titanium anodization layer. As you add more batteries, it'll build up and become thicker and reflect different wavelengths of light. So that didn't have too much of a difference. And I'm dripping water all over my desk. Apparently paper towels are a necessity here. But if we take a quick look here, I can see that I've got a very nice purple. I've got my blue and purple from earlier. And this was the next experiment I was going to try. I've got a bag of rings here. Poke some holes in the bag, so I've got some loose ends. I'm going to create a new little hook. So I'm just going to shove this hook down into the center of these and just see if just through contact I can create enough of a reaction. Is that going to be long enough? Probably not. Here's my other one. We'll use a longer one. Just through contact, can I stir around these rings enough so that I can anodize rings on their own? So I'll put my clip on the end of this. I'll put the clip in the bag. I'll semi-seal the bag. And I'll drop the bag in there. Now the solution's going to go in there. Hooks in the bag. It's making some contact with the rings. Probably want to hook it into them. Let's see if we get any sort of anodization here. There's not a lot of area of connection there, but I think it's starting to change color a little bit. Not nearly as quickly as before. I don't think the solution is used up or the batteries are used up. I think it's simply a case that I haven't created a lot of a connection between these rings. So I'm going to shake them around a little bit. I've got a connection there. And I'm seeing some color change. Oh yeah, I'm seeing color change now. It's definitely heading towards that purple. You can see it how much darker it's gotten already. So give it a couple more seconds. Shake it once or twice to see if we can get a better connection on some of the rings. And let's pull this out and see what we got here. It's a little drippy. Match up a couple of the rings. Oh yeah, that's some dark. That's some purple right there. If I take a look at, I got another bag of rings I haven't anodized yet. You can see a clear difference there. That's 3 9-volt batteries. It's all that took. Crazy, cray. I love it. It's a beautiful purple too. I mean, it's really, really vibrant. And I'm shocked that I got this level of color out of it. That's awesome. All right, I'm going to take a break. I'm going to go get some more 9 volts. I'm going to hook in a couple more and see what we get. Okay, so I've got an interesting discovery here. Now I've got 8 batteries chained together. I got a different set of color ranges off my titanium patch. Let's turn that so you can see it a little more clearly. Specifically what I've got here is, this was 3, 4, 5, 6, 7, and 8 batteries chained together across the titanium patch. And I kind of got like this pinkish purple starting to show up on around 8 batteries. But this was in the titanium patch. What's interesting is that when I did the same with the chain towards the end, rather than getting that same pink, I got more of a golden bronze towards the end of the series of batteries. And this basically tells me that the oxidation layer on the rings is a different level or a different thickness than is on the patch. So I'm getting different colors out of the titanium chain than I am out of the titanium plate. So I got this nice almost golden here of the last batch. And what I'm going to do is I'm going to have one more battery in the series just to see what the heck happens at 9. And then dip my last batch of, or dip a batch of untouched titanium rings in there and see what we get. That'll probably be the conclusion of today's experimentation. But I'm having so much fun with this. My wife will never forgive me for making this. Okay, so once again, we're going to connect to the positive side with our red lead as opposed to the negative side, which is the other red lead. Okay, we're going to disconnect this. And what I want to do is grab my hook, which I was using earlier, to anodize rings. Actually, let's grab it from the unanodized end. I'm going to stick it in yet another bag of rings. And we'll dip it. Let's see what we get. And the solution has filled the bag, and the rings are changing color. Very, very quickly changing color. I can see the color change as the oxidization happens. It goes to purple now. It's going to a lighter blue. It's already starting to get lighter again. And it's kind of hovering in that pale blue. All the rings are covered in bubbles right now as electrolysis is taking place. It's very, very pale. It's gone almost back to its original shiny titanium. I'm guessing it's probably in one of the almost yellow stages. And we'll give it a little more time to build up that coating. Shake them up a little bit more. And it's definitely shading towards yellow. You can definitely see it's gotten a lot lighter. Much, much lighter. And we're going to give it some more time for that oxidation layer to build up. Excuse the stutter. Definitely more towards the yellow. You can see the color change. It's gone well past this initial purple. And let's see if we get close to the pink at least, or at least a bronze. Shake that up a little bit, see if we get a little better contact. Still seeing a lot of bubbling, which means oxidation is still taking place. It means that layer of titanium oxide is slowly growing, and it's changing the wavelength at which it's refracting the light. It's definitely gotten to more of a golden shade. So I'm guessing the more rings I have in there, the longer this is going to take, at least with 9-volt batteries. I have no idea how long these 9-volt batteries are going to last doing this. This is totally just a game of experimenting and seeing what the heck I get. Still seeing bubbles come up, but it's staying in that golden yellow stage. I might be seeing a hint of rose in there. So it's voltage and time determinant, the colors you're going to get. So it's going to be tough without a voltage meter or a professional anodizer's kit like you get from the Ring Lord, which is about $200 plus shipping. It's going to be tough to control the exact color range you're going to get. But getting color seems to be no problem at all. The other thing I've heard is that using TSP, trisodium phosphate, which you can get at most hardware stores. I know Ace Hardware had it. Instead of baking soda, creates a better electrolyte solution, which will result in more vibrant colors and probably quicker anodization. All right, so I'm going to pull this now. Let's see what we got here. It's definitely moved towards the wet stage, but I'm seeing a golden bronze brownish color in there. Not quite to rose. As you can see the difference between the plain titanium and what I've just anodized. But interesting. All right, so this has been my titanium anodizing experiments. I was tempted to try a couple more things, but I think I'm going to take a break for tonight. I already popped the lead off the battery there, incidentally. I'm going to leave one of my titanium plates pristine, just for comparison. And good luck, and if anyone else tries this, I'd like to see a video or a picture of results. Take care.